back. You want to find area under the curve y equals fx from x equals a to x equals b. So this shaded region S, you subdivide S into n number of strips. Okay, n could be 10, 100, whatever. So you divide S into n number of strips, okay, of equal width. So use equal width, okay. So what would that width be? See, the entire length from A to B is B minus A. Big number minus small number is the entire width. There are n pieces in each width, equal pieces. So the width of each piece is the entire length over n. That width is called delta x. Okay, it's just the name. Delta x represents the width of each strip. So these strips divide the interval AB into n subintervals. x0 to x1, x1 to x2, x2 to x3, xn minus 1 to xn. What are these xi's? Go back. You see x1 there, x2 there, x3 there, and xn minus 1. A is x0 because that's the one before x1. And B is xn because that's the one after xn minus 1. So x0 is nothing but A, and the last one is nothing but B. So you have cut your interval A to B into n subintervals. What are the right endpoints of each intervals? Well, for the first one, it is x1. That's a right endpoint. How do I understand this right endpoint? Well, I take this A, that's the first number, x0, add width. Likewise, what is the second right endpoint, x2? Well, I start from A, that is x0, and add one width and one more width. So 2 delta x's. x3, well, start from here, one width, another width, and another width. That is 3 delta x's, and so on. So every endpoint, so x1 had 1 delta x, x2 has 2 delta x's, x3 has 3 delta x's. So xn will have n delta x's. All right. Let's approximate the ith strip. So somewhere here is ith strip. By a rectangle, width is delta x and height is fxi. Height is, I'm using the right hand point. Okay. So that's the rectangle. Notice it's taking a little more here. All right. So if it's under the curve, well, the curve is lower, so my rectangle is slightly bigger. Here the curve is higher, so my rectangle is slightly smaller. Okay. Overall, in the long run, they will a little more here and a little less there will eventually even out. That's the idea. Area of this ith rectangle is its width times the height. Height is fxi. The value of the curve at the number xi is fxi. Fxi times the width is delta x. If you have forgotten what was the width, width is the entire thing over n. So each rectangle, every rectangle has the same width, b minus a over n. All right. So what is Rn? It is the sum of the areas of these rectangles. R stands for right endpoints. So we are taking the height of each rectangle to be the value at the right endpoints of your intervals. So fx1 times width, that is for the first guy, x1 height, fx1, and width is delta x. For the second rectangle, f of x2 is the height and width is delta x. And going on, fxn, the last guy, height at b and width is delta x. The same width for everyone. Okay. So here are different approximations. I'm using right endpoints. There are two rectangles. So you take your curve. That's one rectangle. That's another rectangle. Here are four rectangles. You take A to B and divide it into four equal pieces, the interval, and use the right endpoint heights. Okay? 8 rectangles, 12 rectangles. So as you take more and more number of rectangles, you are going to get better approximation. I hope you understand. This had only 2 rectangles. So actually, if you look at the area of this plus the area of this, it's not going to be very close to area under the curve because you have actually missed out a lot of area here. This is slightly better. You have missed out some area, but you have a little more area here. It looks reasonable. This is even better. This is so far very good. But you really should be taking n going to infinity. Okay? So, which brings us to the area definition. The area A of the region S that lies under the graph of a continuous function f is the limit of the sum of the areas of approximating rectangles. A equals limit n approaching infinity of Rn, which is equal limit n approaching infinity fx1 delta x plus fx2 delta x plus dot 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 fxn delta x. It can be proved that the limit, so this is definition, it always exists if your function is continuous. It can also be shown that this limit is same as the limit when you take left endpoints. So fx0, fx1. So notice the width is the same. But why is this fx0 instead of fx1? Let's go to the picture. Here is an example. This is x1, this is x0. You see? A is x0. If I choose the height corresponding to A, that will give me, for this rectangle, left endpoint height. If I choose x1, then it gives me right endpoint height. Okay? Height corresponding to right endpoint or height corresponding to the left endpoint. These are two different numbers, right? So where are we? For left, I'm choosing the left endpoint heights. For right, I'm choosing the right endpoint heights. Okay? So I will stop this video, not here, well here, okay? Until the next one.